So I'm going to sweep through a number of great ideas and great individuals, probably not giving adequate justice to any of them, but hopefully it will be enough to provoke people to go and do the real in-depth work that's required to really know and own these ideas. Because ultimately that's what's required, is they have to become a living part of your own soul. Now, I just want to start first with, Michelle, can you go down there? I want to start with the first image here. People have all seen this, I'm sure, by now. This is the World Landbridge. And this is actually what's driving everything that's going on in terms of the Asian Infrastructure Development Bank, the BRICS Bank, the new Silk Road of Xi Jinping. All of these developments, the new Nicaraguan Canal, the new Suez Canal, are all being vectored towards this, whether those people that are involved know it or not. And in probably most cases, they're not even aware of the fact that the activity that they're engaged in is being vectored towards this idea. But this idea is more than just lines on a map. Here we're talking about a real transformation of the entire planet, in the sense of bringing together all of the nations of the planet around a unified mission. And as Mr. LaRouche has said, we have to now start to think about the Earth as a single process within a much larger process of, at minimum, the solar system, but ultimately in terms of a galactic process and an extragalactic process. Now, one of the key things here, and this is what I really want people to start thinking through, is that, as I said, these aren't just lines, and they're not just future railroads. These are whole corridors of development. This is the idea of unlocking the whole potential of planet Earth in terms of the fossils of the Earth, the resources of the Earth, and most importantly, the noosphere of the Earth, the noetic powers of the human beings which inhabit the Earth and have inhabited the Earth. But what's going to be required to really make this a living reality? I mean, for example, things like this. This is one of the most beautiful aspects of it, this Bering Strait connection, where you would have either a combination of one or the other of a bridge or a tunnel connecting across the Bering Strait, which would enable you to literally link up the entire globe with rail, with corridors of development, communication, what have you. But really, are we talking about here? What kinds of projects, what kinds of processes go into this? One thing to think about is cities, new cities. India, with their new president, Modi, has said he wants to build 100 new cities. You think about that. And in the process, he's talking about creating 1 million new jobs per month. Not 1 million jobs a year, 1 million jobs over the course of the next decade. He's talking about 1 million jobs per month. So you think of what goes into actually building a whole new city. I mean, in my lifetime, I've never seen a new city built here in the United States. They're talking about building 100 of them. Now, it seems like that could be a process that would take 100 years. And you start to think about this whole project. I mean, in the mind, you think in terms of current practical application, this seems like something that could itself take 100 years or more to actually have all of this rail, all of these new cities, all of this development. But in fact, it's something which could occur literally in the course of maybe a decade or two in terms of full completion of this thing. I'd say maybe a little longer, because really the thing that's, I think, the real limiting time factor ultimately is going to be, do we have enough people mentally capable to carry out this kind of process? Now I'll get at actually the higher ideas that would be involved, but I'm saying even just simply, do enough engineers even exist on the planet right now to carry this out? You know, people have some level of technical skill to just run a machine tool or what have you. So that's going to take some training, that's going to take some development. But what it's going to really take is going to take some serious breakthroughs of principle in physical science. Because to carry this out, to do things like building thousands of new cities around the planet, is going to require a lot of power. And the only thing that we know of at this point in human knowledge which can provide the adequate amount of power to realize this is fusion. Nuclear is a good step, and in fact, India, in realizing what was going to be required to build 100 new cities and what have you, have now taken on a mission to triple their nuclear capacity, because they have not fully conceded to, as Dennis said, the religion of environmentalism. Because just anyone who's thinking, quote unquote, practically, that thinks about, hey, we got to build a new city, we got to do X, Y, and Z, realizes you're never going to produce what's required with windmills or with solar panels. It's just, despite what your religious beliefs might be, the physics of it just don't allow for it. You know, the sun's not going to magically get 10 times brighter and, you know, and impinge 10 times more sunlight onto planet Earth. There's physical limits to actually the ability to use solar power to carry out a process, even with 100% efficiency and with, you know, gale force winds blowing 24 hours a day, 365 days a year. Those kinds of technologies are never going to allow you to have the density of power required for this kind of industrial process. But there's a lot, so fusion is really going to be the key, unlocking the potential of fusion. You do that and things can start to take off so rapidly. I mean, I was just looking earlier at this video in China. They, in the course of 24 hours, they were able to produce 10 houses using 3D printing. I don't know if people are familiar with this technology, but this is sort of the new thing, 3D printing, where you literally are printing houses, full-scale houses, using these three-dimensional printers, which basically take pulverized material, you know, very finely pulverized material, and you know, they can do it with steel, they can do it with concrete and other things, where it's then pulverized and then it uses either lasers or some other kind of heating technique where they can just literally print out buildings and what have you. I mean, this stuff is still in the, still in the infant state, but that's the direction of things. So, you know, the best they've been able to do, 10 houses in 24 hours. That's not bad, right? Much better than the slave labor that was behind the housing bubble here in the United States. So you're talking about, you know, but this is robotics. This is big robotics, and this is, so you start to think now in those terms, wow, what if we actually had a full-scale industrial economy that was producing those kinds of capabilities, those kinds of robotic capabilities that were able to start to build new cities. Now I think even a greater challenge is going to be something like, think about what would go into rebuilding and recycling a city like New York. Because in many of these places you're going, you know, it's a Herculean task. They're going into a barren area and they're just sort of building a new city. An even greater task would be, think about what it would be required to rebuild New York City. There are certain elements of it you want to preserve. You know, like the other couple of days ago, I was up at the City College of New York. Some beautiful buildings there. Those, we're going to leave them. Some of the garbage that's around it, we're going to, you're going to want to level it and start anew. But think about that. How long does that take? You know, how long does it take Donald Trump to throw up one of these, you know, junk towers along the Hudson here? Right? He has to sort of tear down one thing, move it all out, then come in and, this stuff takes a while. How long would it take to rebuild the entirety of Manhattan? Well, this is something that could actually be done in fairly short order if you had, for example, some of the other aspects of fusion technology, like the fusion torch. People are familiar with this, but with the fusion torch, what you're talking about is using the kinds of plasmas that are involved in the fusion process. Plasma is a very hot gas, right? It's a gas which is raised to a temperature where the electrons are basically stripped from the nucleus, and these things can reach upwards of 10, they've already achieved plasmas which are many times hotter than the sun. You're talking about 10 million degrees plasmas. Now you get these plasmas, and what they're able to do, they've demonstrated the capability in the small, and it's never been really fully developed in terms of the engineering feats of it, but you can start to feed material, literally garbage, junk, anything, through the plasma. It'll break it down into its constituent elements, and then because each element has a different weight or a different magnetic characteristic, you can just separate out all of the individual elements. So you can literally take, one of these dilapidated buildings, smash it down, feed all of the stuff through one of these fusion torches, separate all of the elements out into their constituent elements, you have piles of whatever elements, and then basically feed those elements into a 3D printer machine, which would then recycle it into a nice new wonderful building. So that's potential exists. We could be doing that. I mean, the kinds of heavy technologies that would allow you to do that don't exist in physical existence today. But the vision and the thought to do that does exist. The potential is very real to where you could literally start to break down, recycle, and recreate whole city blocks in the course of, I don't want to put a number on it because I don't know exactly, but in fairly short order. And you could start to rebuild and make again New York City and other cities fully beautiful. Not just a couple buildings, not just little pockets, but and do that in conjunction with building whole new cities. So that's the kind of thing that we could be doing, and that's really what's involved in this kind of process, is a total transformation of the planet, a total transformation of mankind's relationship to the solar system. But to do that, some key breakthroughs are going to have to occur. One of the most principal breakthroughs is in the area of fusion, which, as we discussed in other places, very intimately tied also with the development of the space program. Right? As far as we understand now, the best fuel for fusion is helium-3. It's actually, for various reasons, it's the fuel. Other fuels that are used for fusion, they can produce a lot of heat, but the radiation that's emitted is neutral. It sends off a lot of neutral particles, neutrons. The problem with neutrons, though they're very effective at heating things and they're very energetic, they're not controllable because they're neutral. Whereas with helium-3 fusion, it produces protons as its reaction product. The virtue of protons is that they have a charge and therefore can be controlled and directed using magnetic fields. So helium-3 has certain virtues that just make it the best fuel for fusion because of the controllability. The fact that not only are you generating heat energy, but you're also generating, basically you can generate proton beams, which can then be used for other industrial purposes, lasering type purposes. It's a directed capability. Problem is, we don't know how to do it yet. They've sort of been able to achieve fuse elements in the small, but the amount of energy and work that goes into it is far greater than what's coming out. And so there's a real problem. I mean, there's the one side, there's the sort of the monetary problem side of it, which is that it's vastly underfunded. So not only are we underfunding fusion, there's also been a process by which they're actually shutting down fusion capabilities. So there's that side of it. we're not producing enough scientists, we're not funding it enough, what have you. But even were all that to change, even were we to get the breakthroughs in terms of the type of economic system we would want to have here in the United States, and put the full billions of dollars, trillions of dollars of funding into fusion, and to start up whole new universities dedicated to that kind of breakthrough, we'd still have the problem that if the kind of science which currently still dominates, in terms of the way we think about how processes operate in the universe, in terms of the method that's applied, even with all the funding, you're still not going to get the breakthrough necessary. And that's really where Kepler comes in. Is that gives you Kepler brings the method which will be necessary to make the kind of breakthroughs that are going to be required to achieve this kind of fusion technology development. So that's what I'd like to get into, is exactly what do I mean by that, and to start to flesh out, at least the skeleton of what that means. Now there's another character that's involved who's integral to this process, and that's Vladimir Vernadsky. Sure, some people have heard of Vernadsky, probably because of our movement, but he's not a figure which is well known in the United States, let's say, except for there's a certain specialized class of people that work in the field of biology and other things who do know Vernadsky, and he's very well respected in certain circles. But in the main, not a well-known figure here in the United States. That's not the case in the Ukraine, where he's actually from, or in Russia, where he spent most of his working life. There, the name Vernadsky is akin to the name Thomas Edison here in the United States, right? He is a towering figure, right? He's a real genius. He's a figure which they are very proud of, and whose name adorns buildings and universities and this kind of thing. We in the basement have really, in the recent period, aside from what had been ongoing years of work on Kepler, we started to really get into Vernadsky in the last couple of years. And then in particular, over the last couple of months, we've really been inspired and have been provoked by a particular paper that Vernadsky wrote, which was recently translated by Megan Roulard. She translated from the French. And it's a paper called Life and the New Physics. It was written, I guess, kind of earlier in his work. It was written in 1931, which I think is actually before he even started to develop his idea of the noosphere, at least before you started to see the term noosphere appear in Vernadsky's writings. So he writes this paper, Life and the New Physics. And basically what he does is he starts off just attacking the Newtonian Galilean system which had dominated physics up to that point. Where he says, this had some value, we got somewhere with it. But he says the problem is, over the course of centuries, a certain kind of problem developed in just the way people think about the universe, think about the cosmos. In effect, it's become a very cold image, a very detached image. Right? You've got these planets, you've got these mechanical systems, but it's very detached from life, from the human mind, from actually really what is the dominant part of our own daily experience. I mean, he makes the point, we all live in the biosphere. We're constantly interacting with life or with the effects of life, from the air we breathe, to the water we drink, to the atmosphere which protects us from the sun, to everything. Our life exists, has always existed, in the biosphere. We can't escape it. Every experiment that we conduct is occurring in the biosphere. Yet, that's been completely taken out of our abstract idea of processes in the universe, of physics. And so what he proposes is that if we're really going to make the necessary advances for mankind, the principle of life, and then beyond that, the principle of the human mind, are going to have to start to play a more dominant, and really the dominant role in our understanding and investigation of physical processes. Right? Hence the idea of life and the new physics. The idea that the principle of life now has to be as integral to all of our investigations as gravitation or electromagnetism. That you can't escape it, so to speak, in the universe. And so in there he starts to look at, in particular, the work of Louis Pasteur, who really kind of set things in motion in terms of what this means. So Pasteur, I'll get to a quote of his in a moment. Trying to think what would be the best direction to go here. Well, let's go. Can you the number 2 there? And can you just scroll down, just bring this one up? I'll get to that second one later. Just go down a little bit. No. Go up to the top of this, yeah. So this is actually from Louis Pasteur. And I think this isn't cited by Vernadsky, but this I think really captures what Vernadsky had in mind. So Pasteur says, I've been looking for spontaneous generation for 20 years without discovering it. Spontaneous generation, that's the idea that life could somehow emerge from a non-living process. Right? People have heard of the so-called primordial soup, where one of the ideas about where life came from on Earth is that you had all these chemicals and hot earth and chemicals all in these pools of water, and one day some lightning struck down, and somehow that lightning was enough to bring some chemicals in, and all of a sudden, poof, you had amino acids, and that started some chain reaction, which then became what we know as life.
The Mars jar?
What's that?
The Mars jar, like Carl Sagan did?
Yeah, right. So the idea of spontaneous generation, that somehow life emerged out of some sort of abiotic reaction. So Pasteur says, I've been looking for spontaneous generation for 20 years without discovering it. No, I do not judge it impossible, but what allows you to make it the origin of life? You place matter before life, and you decide that matter has existed for all eternity. How do you know that the incessant progress of science will not compel scientists to consider that life has existed during eternity and not matter? You pass from matter to life because your intelligence of today cannot conceive things otherwise. How do you know that in 10,000 years one will not consider it more likely? How do you know that in 10,000 years one will not consider it more likely that matter has emerged from life? You move from matter to life because your current intelligence, so limited compared to what will be the future intelligence of the naturalists, tells you that things cannot be understood otherwise. If you want to be among the scientific minds, what only counts is that you will have to get rid of a priori reasoning and ideas, and you will have to do necessary deductions, not giving more confidence than we should to deductions from wild speculation. So that's a pretty radical idea, provocative. The idea that life is what's eternal. Life is what was there, and matter, stuff, came from life. That actually, from that standpoint, all of what we think about as abiotic physics, really, or not, non-living physics, mechanical processes, actually has its origin in a principle of life. Which would mean, for example, gravity. Right? If you look at what Einstein did with gravity, the idea of the general theory of relativity, right, that the field, the gravitational field, is bent by matter. So that if you look at, the sun, if you were to look at sort of the gravitational field of our solar system, it would be bent towards the sun. And that was part of Einstein's discovery, was that the gravitational field is bent by matter. And so the shape of the gravitational field is determined by the shape of material. More massive objects have a greater effect on the bending of what he called space-time, gravitational space-time. Now, if in fact we get to a point where we have the understanding that Pasteur is alluding to, that matter, that which actually bends the so-called space-time field, has its origin in life, well then, in that case, even that which we only look at from the standpoint of non-living systems, like gravity, would actually itself be a derivative of a living process. And would therefore be much more, would be better understood and characterized by the types of unique qualities which we only find in living processes. So, for example, this is something that Vernadsky was very keyed in on in terms of what Pasteur was doing, which is looking at this quality of dissymmetry or asymmetry, which you find uniquely in life, but which you don't find in abiotic systems. So what he means by dissymmetry is that life, that in abiotic systems you have, or in abiotic space-time, just to put it more broadly, there really is no distinction between left and right. You know, if you try to describe left by itself, it's impossible. It's sort of one of the big challenges of... Yeah, right. This is one of the big challenges that people, that geometers and others have been wrestling with. You know, could you describe to someone what left is? You have to refer to right. You'd have to say, it's the thing, it's the opposite of this thing, right? You always have to give them together. And it's sort of arbitrary which one you call left, which one you call right. Just like up, down, whatever. So in abiotic physics, there's a balance, left and right. There's no distinction between the two in so-called Euclidean space. In life, it's different. Life does distinguish between left and right. And this is one of the things that Pasteur discovered, was that, so for example, what he looked at was racemic acids, which are these crystals that are produced largely in fermentation. So if you produce racemic acid through just a chemical process in the laboratory, you're going to get both left and right-handed versions of the crystal. What I mean by that is that it's, you know, the racemic acid has like carbons, hydrogens, and other things. It's a molecule. And it has a very particular arrangement, but it has both left and right-handed arrangements, like your hands. Right? Your hands are all, in terms of the components, are made of the same thing, right? Both hands have a thumb and 4 fingers and what have you. But their orientations are opposite, right? You can't get your left hand ever to match your right hand in terms of, right? If you try, I mean, you do this, but that's not actually, you're not imposing it, you're using one side versus the other. So you have left and right-handed forms of these crystals. And in the lab, there's no distinguishing between them. They're produced in equal amounts whenever you try to produce them through a synthetic, just chemical process, by putting a bunch of chemicals into a soup and maybe seeding it with some crystals, and it'll start to grow. It'll produce equal amounts of left and right. But whenever you look at a living process, when you look at fermentation, which is a living process, Pasteur found that life always consumed the right, I think it was the left-handed version of the crystal, and left the right-handed version. And this was very provocative to him, because from the standpoint of the elements involved, there's really no distinction. The only distinction is the spatial orientation of them. But in terms of both left and right, both have the same number of carbon, the same number of hydrogen, the bonds are all the same. From that standpoint, they're exactly the same. The only distinguishing character is that one is left-handed and the other is right-handed. Yeah.
What can life count of?
What's that?
What meaning life? What can life count?
What can life recount?
Yeah.
What do you mean by that?
Physical life, physical cell life, and any metal have around electron, proton, neutron. This is called one kind of life. Human life is different. Another life, mechanical life is different. What can life count?
Yeah, well, that becomes the question. How does life know the left and the right? Why is it choosing one versus the other, whenever chemically they're both exactly the same? And that became the question. That's, Pasteur didn't have an answer for it, but that was the question. It was like, well, what is it? Life does seem to have a orientation, does seem to have a handedness, while space, abiotic space, seems to be indifferent to left and right. Life seems to be very preferential to choosing one hand, so to speak, versus another. So this became a real provocative idea for him, was that, okay, there seems to be something very unique about life that's not there in abiotic systems. In non-living systems, left and right make no difference. In a living system, left versus right make a fundamental difference. Yeah.
Well, if life existed in space before matter, what form or shape would it appear in space? Would it look like matter? Would it be like a spirit in space? I mean, what form or shape?
That's something you have to think through, yeah. Those are all provocative questions. But this is what provoked Pasteur, was that, okay, life seems to have a different space than non-living processes. The space of life is different. Vernadsky then took it further to look at the time also. See, in non-living processes, in mechanical systems, there's no real distinction between a process that moves forward in time and that same process going backwards in time. In terms of the physics of it that are involved are really indistinguishable. Even though it seems ridiculous, the idea of, say, me taking an arrow, pulling it back, shooting it, it hits a target, everything that's involved, all of the laws that I would use to calculate its velocity, the weight, how it would hit, etc., can all produce that same effect in the reverse order. Now, you're not going to see that, but it's possible. There's no distinction. It lawfully could occur, right? For the arrow to sort of come out of, for a force to pull the arrow out, to bring it back in the same trajectory, to come into my bow, and to recoil the string. There's no distinction from the standpoint of the mathematics, the forces, and the physics involved. So time, from the standpoint of mechanics, can go forward and back without any distinction. Not the case with life. Right? Life always has a very definite directionality to it. Evolution goes only in one direction. And it's a direction which has some very interesting characteristics to it. It has a nonlinear quality to it. Right? Evolution does not occur as a function of sort of an additive process. I mean, you just take something fundamental to life on the planet, such as photosynthesis. Still a mystery where photosynthesis came from, how it came to be. Because at one point there wasn't photosynthesis. There was a certain, the planet existed in a certain way. Once you get photosynthesis and the ability of life to capture the energy of the sun and to use that energy to transform and create chemical reactions, etc., transform the planet in a very distinct way, in a very directional way. Right? It moved it from a certain level of organization and power on the planet, right? The rate at which things changed on the planet, the rate at which the atmosphere was changed. All of that went through an upshift once photosynthesis as a capability was introduced into the biosphere. Similarly with other things like warm-bloodedness. right? Once animals became capable of regulating their own internal temperature, you now had the ability for life to be more abundant, to exist in more diverse types of climates, to travel further. I mean, there was a whole transformation in terms of the power of life on the planet to act once there was a, in a sense, discovery, for lack of a better term, on the part of the biosphere to figure out how to control and regulate its own temperature. Whereas prior to that, the temperature of an organism was very dependent on its ambient environment. Right? If the ocean was cold, that animal was cold. If it's cold outside, that animal's internal temperature was cold. Got hot, it got hot, etc. Now, once you had this ability for internal regulation, so-called warm-bloodedness, now, you know, the ambient temperature is much less relevant to your ability to maintain living functions. Obviously up to a limit, but, you know, there's a transformation. So if you look at life, it's always got a direction to it. It's got a very distinct direction. There's a very distinct difference between going forward and going back. And Vernadsky showed that, okay, so here again in life, time is very different for living processes than it is for non-living processes, or from the standpoint of mechanical physics, abiotic physics. And so his idea was, well, okay, there's something, the space-time of life is fundamentally unique and distinct from the space-time of the abiotic, from the space-time of the mechanics, from the space-time as described or understood by the likes of Newton, Galileo, etc. And so this became a real driving question for Vernadsky. And that's really what he poses in this paper. He's saying, okay, well, what if we now say, instead of looking at life as a anomaly, what if the characteristics and qualities which we find in life are actually the more fundamental characteristics of the universe as a whole? What if these qualities of asymmetry are actually fundamental, that the non-difference between left and right, those are the anomalies. You know, the things that we find in so-called abiotic processes, those are more anomalies, or just limited windows of reality. But that the larger reality is actually governed by principles which we find more associated with living processes, like a directionality to the space-time characteristics of things. And so that was the idea he put forward, to say, if we're going to make the necessary and required breakthroughs in physics, in understanding the cosmos, in understanding how our solar system, how the galaxy works, etc., we're going to have to move beyond where we've been up to this point. And what happens if we now start to look at these phenomena like a galaxy from the standpoint of life? What if, instead of assuming that a galaxy is just a abiotic process, is just a mechanical process governed by, you know, electromagnetism, gravity, mechanical forces, what if instead we look at a galaxy and we start from the idea of, well, what if that's something that's alive? What if the galaxy is a living phenomenon? Now, how do we understand it? It's a whole different approach. It's a whole new way to conceive of it. And so this is something that has really been a provocative driver of all the work we're now doing in the basement. To say, okay, if we want to make these kinds of breakthroughs, such as in fusion, maybe the problem that's occurring in our understanding of these plasmas and our ability to organize the plasma in a way that's going to achieve a fusing at a rate which is greater than the amount of energy and work that goes into it. What if our ability to make the breakthrough is going to require us to move from looking at these plasmas as just abiotic mechanical processes, and now start to think about them from the idea of a living system? And I mean, I don't mean that in some kind of weird way, like, oh, it's a creature, it's a living creature with its own. But what if the physics of it are actually more consistent with the kinds of quote-unquote physics of life? how then do we understand it? How then would we start to shape our experiments? How would this inform the way that we organize our approach to these plasmas? At an even higher level would then be to then introduce the laws of the noosphere, the laws of creative mind, which are even more anomalous from the standpoint of abiotic physics. And this is something which, very much may be what's occurring whenever we start to look at these quantum processes. Right? People have all heard of things like the particle wave duality, right? When you're looking at something like a photon, certain experiments show that quantum phenomena act like waves. So if you have you can set up an experiment where you're shooting what you think are individual electrons or photons or what have you through a screen that has 2 slits in it. And so you have you have something set up where you've got 2 slits in a screen or some sort of barrier. And you would think, okay, if I'm shooting electrons at this, the electron either goes through the left slit or the right slit, or it doesn't go through at all. And on a screen that's behind the barrier, you would expect to find, for those that pass through, a bright spot here and a bright spot here, which correspond to one of the 2 holes that these electrons pass through. But when you set up the experiment and do it, what you actually get is not what you would expect from throwing hard balls through 2 individual slits. What you get on the screen on the other end, over time, you do this thousands of times, millions of times, you actually get a pattern which looks like the same kind of pattern that you get with wave interference. So, like whenever if you set up that same kind of 2-slit experiment in, say, a pool of water or something, or just with light, you just shine like a bright light at it, you get this wave, you get these lines of alternating light and dark, light and dark, light and dark, which is the result of waves, light waves, engaged in constructive and destructive interference. Right? When waves interact, they either amplify each other. If 2 crests meet, they'll amplify each other. If a crest and a trough meet, they'll cancel each other out. So whenever 2 waves interact, or 2 wave systems interact, you get alternating constructive and destructive interference. So alternating lines of bright and dark. Well, that's the pattern that emerges whenever you conduct this experiment. So here you've got something which is individual hard electrons, individual things, which are producing a wave-like effect. Conversely, what Einstein had discovered based off of Planck's work was that light then, which typically manifests itself as a wave, actually has characteristics which are particle-like. That light, which up to that point had been thought of as a wave phenomena, actually has a discrete quality to it. And this came through in his discovery of the photoelectric effect, which I won't go into now. But the point is, you have, at the level of the quantum, you have this paradox, where the question is the quantum, is it a wave or is it a particle? Is it both or neither? It's paradoxical because they're somewhat contradictory. The wave and the particle seem to be contradictory types of phenomena. But yet it's both, it's neither, it's one, it's the other. Well, to me, that quality of existence is very much the kind of thing you find in, for example, in poetry. Right? In poetry, words can mean this, that, or neither. I always think of the, Shakespeare has a lot of these, which are very clear examples, very simple ones. But there's the one sonnet where he talks about lying with his wife. I forgot, I don't have it memorized, but something like, I lie with her, she lies with me, and together everything is great. But it's very ambiguous how he's using the word lie. Right? Lie could mean, the one way it implies that they sort of lie to each other and tell each other, oh, honey, you look great. Honey, you're wonderful. Oh, yes, you are too. So they sort of lie to each other, which kind of, makes for a nice, happy, get-along marriage. But then they also lie together. They're lying in bed together. But in the poem, it's not one or the other, right? Shakespeare didn't write it with, this means this, and if you think it's the other, you're just misinterpreting it. It's intentionally written to simultaneously be both, where the use of the word lie means both to lie down and also to lie, to tell to fib. But it also doesn't mean either, because his point isn't that there's some definite meaning in the poem. The point is that there's something, he's really trying to get at something which is unique about the human mind. The quality of irony, the principle of metaphor, where reality exists not as this or that, but the reality exists as both this and that, and neither this nor that. So when you go into the domain of the noosphere, into the noetic, a lot of these things, which from the standpoint of simple physics, like wave-particle duality, which seem to be contradictory, which seem to be completely nonsensical, actually start to resonate in terms of the lawful, it becomes a lawful characteristic. This dual nature of things, this contradictory nature of things, becomes a lawful quality when thought of from the standpoint of the mind, the way the mind works. Because that's how the mind works. The mind works according to contradiction. And this is something, we've discussed this a lot with the work of Kuza, right? Kuza's, I can't remember the name of it now. The one where the coincidence of opposites. Right? Nicholas of Cusa has a paper called The Coincidence of Opposites, where he discusses exactly this. When you're trying to discuss something like God, well, you can't put a label on God. You can't say, I forget exactly how he formulates it, but he just makes the point, a concept which cannot be nailed down in that simple sort of definitional type way. Right, as Dennis was talking about, something like a noetic prayer or something. You can't put a definition on it. All you can do is you can sort of refine the poetic nature of it. You can, and that's why Mr. LaRouche once wrote a paper called Why Poetry Must Supersede Mathematics. Because to really know a process is not to know it as a definition. It's to have it as in a sense, as a poem in the mind. To sort of have a lawful embodiment of the irony of the process. That's what it is to really know something. It's not to know it as a thing or to know it as a definition, but to have a lawful sense of the irony of its existence. What is the ironic metaphorical characteristic of its existence? That's to really know it. And so I think once we start to apply that kind of thinking, this poetic quality of mind, to these processes like fusion, these hot plasmas, once we start to say, well, how would I construct the experiment in order to, or construct, set up the design to achieve fusion from the standpoint of the poetry of the design, as opposed to saying, what are the simple mechanical actions that are involved, to say, okay, well, maybe if I approach it from the standpoint of a space-time of life, or I approach it from the idea of a space-time of cognition, now what kind of experimental design would I want to use to achieve fusion? And so I think that's going to be key. To take that kind of approach is going to be key to making these kinds of breakthroughs in the domain of physics, in the domain of fusion, which is going to be absolutely necessary to achieve, what I initially showed there as the Eurasian Landbridge and everything that goes along with it. So that kind of is one idea. I'm just trying to think. It's 4:30 now. I mean, I have some other stuff I could look at, or we could sort of stop now and take
You
some
wanna take
questions.
some questions?
'Cause I mean, I did bring some stuff on the Kepler, which we just didn't have a chance to get to. First, let me actually though read this quote from Max Planck, because this also very much gets to the point. Michelle, can you go down to the next page there? Okay, let's go to the top of the page. So this is Max Planck. People familiar with him?
Yes.
Right, this is a guy who discovered the idea of the photon, or I mean the quantized nature of phenomena, right? He discovered quantization.
But I have a question.
Yeah.
Quantum field is wonderful. We can say that we can Einstein show the equation. Like in the past the times, that's all time fast.
Say that again?
Time all time fast. The phenomenon can pass the time.
Uh-huh.
So, my question, how can I see the light? We can see the light, but triangle face, if you not make a triangle face, we cannot see the light.
If you make a what now? A
Triangle face, only electron or only proton or neutron,
yeah.
we cannot see this one.
Yeah. Oh, you're saying how they see it whenever you set up this experiment?
Yeah.
Oh, they set up like a detector screen behind the two slits. So they're able to set up a thing that detects when a photon hits it or whenever an electron hits it.
No, this equation for the electron all time 45-degree angle.
Yeah.
Then we see the light.
Yeah. Maybe we can talk about it afterwards.
It's
We'll
done
see.
in the dark.
What's that?
It's done in the dark, and they shoot the photons, and they create
Yeah.
magic in the dark.
Yeah.
And that's when they see it moves through the slits and go.
Yeah. But yeah, we can talk about it after. But I just wanted to read. So this is Max Planck. This is a guy who was, the preeminent physicist of Germany. Made a great number of discoveries. Discovered the quantized nature of light, among other things, and was, like I said, he was the preeminent physicist of his time and Nobel Prize winner, et cetera, et cetera. So here's what he has to say. And this is from a speech he gave in Italy. I forget the exact, it was the latter part of his life. So he says, "Gentlemen, as a physicist who devoted his whole life to the sober science, the study of matter, I'm surely free from the suspicion of being taken for a Schwarmgeist." Schwarmgeist being someone who believes in spirits and ghosts and all this kind of thing. So I'm free of suspicion of being taken as a Schwarmgeist. And so I say of my researches of the atom, there is no matter as such. All matter arises and exists only by a force which brings the atomic particles in motion and keeps them together as the tiniest solar systems in the universe. But as there is neither an intelligent force nor an eternal force in the whole universe, this is the long-awaited perpetual motion which the humanity failed to reinvent, we must assume a conscious, intelligent mind behind this force. This spirit is the basis of all matter. Not visible, but ephemeral matter is the real, the true, the substantial. You scroll down a little. Because matter would not persist at all without spirit. But the invisible, immortal spirit is the truth. However, since mind by itself likewise cannot exist, rather every spirit belongs to a being, we must necessarily assume spiritual beings. However, since spiritual beings cannot exist of themselves, but must be created, so I do not hesitate to call this mysterious creator, as have all the civilized nations of Earth of earlier millennia, God. With that comes the physicist who has to deal with matter, from the kingdom of substance into the realm of spirit. And with that, our task is over, and our research must continue in the hands of philosophy. The more laws are revealed to us, the more forces, powers reveal themselves to us, the greater the reverence for a force power that is behind everything. And then he just goes on and says, I'm a deeply religious person, but I believe neither in a personal God what's he say? I believe neither in a personal nor a Christian God. So he actually was a pretty Christian fellow. But, so here you got the preeminent physicist who, like you said, spends his whole life studying matter. Studying light, studying matter, all this stuff. And towards the end of his life makes the conclusion, there is no such thing as matter. All there really is spirit, or what he says, mind. Mind is what's real. Mind is what prevails and what's dominant. And so that's, again, I think we take our points from who better than Max Planck in terms of how we need to approach some of these problems in the quantum and in physics in general. So I'll just, I guess.
Well, you have about 15 minutes. You should probably do some stuff on that.
Okay. Okay, so in that vein, let me just kind of give an overview of exactly what Kepler did in his discovery of the solar system. Because what he did is he also leapt beyond the world of simple matter and simple forces and said, what would the universe, or what would the solar system look like as created by a intelligent mind, which is of which my own mind is the image. Right? People have heard this idea of man as being created in the image of the Creator. Well, Kepler deeply understood and followed that idea, that just as his mind is in the image of the Creator, the creation must also be imbued with that same quality, such that the mind of the created, but the uniquely created human mind, will be capable of understanding and knowing what that creation was. We'll be able to know the creation. And so, can you just go to number 2? Number 3, sorry. All right, so this is, people may have seen, this was Kepler's first model of the solar system. This is from his book called Mysterium Cosmographicum. And basically what you're seeing here is that he's got these shells here represent the orbits of the planets. And in between the shells, he's got these solid figures. They're known as the 5 Platonic solids. So for example, you've got here the cube, which lies between what was the outermost planet of his time and the second outermost. And it goes on and on and on, into Mercury. So what his initial idea was that, okay, well, we got to approach the solar system not as individual planets with forces acting on them, etc., or as had been done up to that time. He was not satisfied with just producing a mathematical model that would describe what's happening in the heavens. He actually wanted to know what was the one idea which governed the solar system and its composition and its organization. So his first idea was that you had the 7 planets all organized according to these Platonic solids, such that the outer, so you got this cube, and the outer orbit would be such that a sphere which had the radius of that orbit would perfectly touch the corners of this cube. And that the inner planet, the planet inside of it, would just perfectly touch the faces of that cube. So that the cube, the ratio of the distance, so you've got one orbit which just perfectly touches the outer cube, so that just the vertices of the cube touch the outer orb. The inner orb would then just perfectly nest inside it such that it only touched the central faces of the cube in this case. So that the distance between these 2 planets would be determined by the distance between the inner and outer touching spheres of the cube. so that the cube, the dimensions of the cube, are what would determine the distancing of the planets. And so then he did that for the cube, then the tetrahedron, and unfortunately you can't see it in there, but then it goes tetrahedron to, I think the next one is the icosahedron, dodecahedron, and I think the octahedron's the last one.
Yeah.
Yeah. So the idea was that the spacing of all the planets would be determined by the nesting of these 5 Platonic solids, which are the only 5 constructible solids which in 3-dimensional space have the characteristic of each solid has all the same faces, all the same equal edges, vertices, etc. It's perfectly symmetrical, however you want to put it. There's only 5 that you can actually construct in 3-dimensional space. And so for him it made sense. Okay, the solar system would be organized according to this very beautiful design. And so there would be one, so for him there was this one idea which composed the solar system. Now, it was very close to accurate. I mean, in terms of the distancing, the ratios that are given, the distances which accord with these ratios as prescribed by the nesting of the solids is actually relatively close to the actual known distancing of the planets between each other, and was actually the most accurate model up to that time of what the actual relationship of distances were between the planets. But Kepler, being as he was not satisfied with simply, and can you go to the next one? I guess what would that be? Number 4. Just sort of another schematic of that same idea. But he wasn't satisfied with this. I mean, his next book after Mysterium Cosmographicum was The New Astronomy, where he takes on the problem of the fact that, as he discovers, the orbits of the planets are not circular. They're in fact elliptical. And so he was one who discovered the elliptical nature of the planetary motions. And he also, in this New Astronomy, also was the first to put forward the idea of a physical cause to the motion of the planets. Whereas people like Ptolemy, Copernicus, and others, they never hypothesized a cause. They just came up with models that would allow you to describe the motions you saw in the sky, but they really weren't concerned with whether or not the models corresponded to physical reality, nor did they ever hypothesize a cause. And what's actually the physical cause of the movement of these planets. Kepler hypothesized the sun, that the sun was the driver, the cause of the movement of the planets. And he then went further and said, okay, well, how would these planets appear? What kind of idea is organized from the mind of the sun? So if you sort of say the sun is the driver of the planets, what does the mind of the sun see in terms of the whole composition? And he then put forward his idea of the harmonic relationships of the planets. So here what you see in this diagram is that these are the different, Kepler's time the planets were only known up to Saturn. So you have Mercury, Venus, Earth, Mars, Jupiter, Saturn. And I think they had some idea of the asteroid belt, but that's a little more ambiguous as to what was really thought in Kepler's time. So here you've got, this is the octahedron, which is nested in that first model, nested between Mercury and Venus. This is the icosahedron, which is nested between Venus and Earth, dodecahedron, tetrahedron, and cube. So these are the shapes as they nest in that nested model. But, and you'll see actually these are too specific in terms of just how close they are. So you see actually the tetrahedron does perfectly fit between the orbit of Mars and Jupiter. It actually perfectly fits in terms of the ratio of the inner and outer sphere. The other ones, this one comes up a little short, this one comes up a little short, this one's a little too big. But you can see they're fairly close. I mean, it's remarkably close, miraculously close in terms of just how accurate that model is to giving you the actual ratios of the distances between the planets. But it wasn't perfect, and Kepler wasn't fully satisfied. So he went on after the new astronomy, once he now had sort of the physics that were required to better investigate the nature and composition of the solar system. He actually went back to an idea which he had hypothesized earlier in the time that he was working on the Mysterium Cosmographicum, when he came up with this nested solids idea. He already had it in his mind that harmonics must be at play here. There must be some sort of harmonic musical quality to the organization of the solar system. Now, after the discoveries he made in the new astronomy, and then an additional discovery which he made during his course of his work on the harmonies of the world, which is really, he discovered what became known as Kepler's third law, which is the fact that the ratio of the time and distance of all the planets, it's distance squared over time cubed. So it's the so-called 3/2 law, right? That the planets are always, the distance of the planets, the square of the distance of the planet is always going to be in proportion to the time cubed of the planet. No, it's distance cubed times squared, yeah. That's going to be a constant ratio for all the planets for any given star. So if you take the ratio of the distance of the planet from the sun, and you take the cube of that ratio to the time that it takes the planet to move around the sun, squared, that ratio is going to be the same for every single planet in the system. And so in that way, he when he made that discovery, he was really ecstatic. Like, now I have some kind of single principle which allows me to further investigate and actually make measurements about where these planets should be, what their speeds are, etc. So with that, and with his idea of the elliptical orbit, he was then able to start to look at the relationships among the planets from the standpoint of their motion. And so he actually, in his book, he has this whole discussion, like, what should I compare between these? So I look at their weights. Maybe if I look at the harmonic relationships of the weights of the different planets. I mean, I should look at the size of the different planets and their relationship. Maybe I'll find harmonics there. He puts out a couple of different ideas, but he casts them all aside and says, well, those are all static. What's actually the action? Where is the action captured in the planet? So, okay, let me compare the motions among the planets. Let me compare the action. And I'm going to look at, in particular, the two singular points of action of the planet. The point in its elliptical orbit where it's furthest away and closest to the sun. When it's furthest away from the sun, that's when it's moving its slowest. And when it's closest, that's when it's moving its fastest. So that's the aphelion and the perihelion. So he said, let me compare the aphelion and perihelion of these planets to each other. And so that's what these numbers are here. Sorry it's not super clear, but these are, so if this was the orb for Mercury, this would be the aphelion, this speed here, in terms, as measured by its speed over the course of a day, its daily arc. And this would be its perihelion. So you can see in the course of the day, when it's closest, it goes much further than it does whenever it's further away. So it's much faster here and slower here. Closer to the sun, faster, further away, slower. And so what he did is he started to compare these speeds as seen from the sun. See, some of the confusion is that the speed is not, it's not speed relative to itself or relative to some abstract space. It's how the sun, the speed it would appear from the vantage point of the sun. And so from the vantage point of the sun, these are the daily arcs. So it gives you the daily speed. So he compared these amongst each other and found that if you look at, for example, what he called divergent motion, which would be, for example, the motion, the two motions away. So this would be the divergent motion of, say, Mercury and Venus would be the speed of Mercury whenever it's closest to the sun compared to the speed of Venus when it's furthest from the sun. Or what he called the convergent motions, which are sort of the inverse of that, which is the speed of Mercury whenever it's furthest and the speed of Venus whenever it's close. They're converging and diverging motions. And he found that, lo and behold, the ratios of the speeds among the planets correspond to musical intervals. And if you can go, Rochelle, to the next, I guess that's number 5. So this is from Kepler's book, The Harmonies, where he looks at the individual planets and looked at what were the interval that the planet itself traveled through. So, like, there's this funny thing about Earth, which goes from me, fa, me. And he said, oh, this makes sense for Earth because it's misery, famine, and more misery. This is the time of, this is a time of pretty miserable time on Earth. So he kind of made this joke. This is during, the religious wars and all this kind of thing. So here, this is what he shows as these are the intervals that the planet itself moves through as it moves through its slowest to its fastest down to its slowest. And each planet has a characteristic sort of range that it moves through in terms of musical intervals. Then he compared them among themselves. Can we go to the last one? And this is unfortunately just sort of a picture, which is not maybe super clear picture from the book. And you see this is him now comparing between the different planets. This one's not as clear actually, unfortunately. If you look it up, you can find, probably on our website, we have some better ones.
Yeah,
But so what he showed was that, between, for example, I think it was between Mercury and Venus, that what he didn't, there it's a little bit different because he didn't look at diverging, converging, he looked at 2 different relative motions. But he found that the 2 relationships that you get between Venus and Mercury are the major and minor sixth, which then he used the major and minor sixth to then distinguish between 2 different types of scales in the musical system, what he called the hard and soft scales, which are roughly correspond to what people now might talk about as major and minor scales. So he found that depending on which method of organizing of the system you want to use, whether you want to use the hard scale or the soft scale, which are going to differ based off of the difference between the major and minor sixth, that you then get all of these ratios between the planet speeds, which correspond, in some cases, almost exactly perfectly. In other cases, deviate by a very little amount, showed that the relationships between the planets are actually of the same relationship that you find in the musical scale. Fifths, fourths, thirds, things like that. That, in fact, the solar system is organized according to a harmonic principle. That there's a musical concept, musical idea, which is there organizing, embedded in the singular construction of the solar system. And so in this Harmonies of the World, he goes through really a working through of that discovery. But it's not perfect. And as he makes very clear, it's sort of tug and pull between the 2, where it's both an organizing and a distancing, which is organized according to the nested solids, but it's also organized according to harmonics. And it's sort of the interplay between the 2 which gives you the totality of the way the thing's organized. It's neither perfectly according to the solids nor perfectly according to harmonics, but it's actually the interplay of the 2 which give you the 1. And it's sort of, which can't be defined by either a sense of hearing or a sense of sight. You think about the geometry of the construction of the solids as sort of the geometry of space, the geometry of the faculty of vision, and then the harmonics sort of correspond to the domain of time, the domain of the auditory realm. That it's neither one of those are ever going to give you a perfect idea about reality, but it's the interplay between them. It's the irony of the relationship between them, between the space-time, the visual, the auditory. It's in there that the real truth of the matter lies. But we can sort of be provoked towards the singular one through the faculties of the sense, through the harmonies of music, through the organization of space through constructive geometry. And really, you see with Kepler, the greatest application of exactly this principle, which I said early on, really, he starts from the standpoint of mind. What is the quality of the creative human mind as reflecting the mind of the creator? And we use that to understand how, in this case, the solar system is organized. But we must take that principle and extend it from the macro to the micro to the quantum scale and say, how does the principle of mind allow us to understand the totality of phenomena that we must master in this universe, in the solar system? And so this is what's required to be brought into these institutions if, in fact, we're going to make the necessary breakthrough in fusion and achieve this vision of a unified planet with this World Landbridge and the idea of then the encompassing of the entire solar system by the noetic powers of the human mind, and then beyond that. So I will end here with that. And I can either maybe take a question or two, but I know, Lynn, you want to get the action.
Yeah, it's okay. We can take 1 or 2 questions.
Okay.
As long as we're done by 5:30, we're okay.
Okay, yes.
Yeah, and everything that you've been presenting to us today, the thing that really triggered something, so this comes out as not sure if it's a question, but it's an issue.
Mm-hmm.
You know, when you went from the discussions of Pasteur and science,
Mm-hmm.
and is it one thing or is it the other or is it neither? And then you went into the Shakespeare poem. And so these ironies and things, it just brought to mind the frustration when I encounter these types of, as you say, the dual nature of things, that the mind works according to contradiction. That when I'm confronted with these types of things in any form,
Mm-hmm.
which apparently includes trying to be a better organizer too.
Yeah, certainly.
The poem really brought it up because whenever I engage in this type of thing, and I avoid poetry, I think for that reason, I become very frustrated. I don't even know if that's the word, or a lot of tension
Mm-hmm.
builds up, and I seem unable to resolve it. So again, I'm not even quite sure necessarily. I just felt the need to raise this.
Mm-hmm.
I'm sure you've heard this before, and perhaps in better organized manners, but it really grabbed me, and I felt like I got to get this out some kind of way to express this type of my problem with how the mind works, if that's what I'm saying, and how sometimes I say it's just because you're old, man. They've done such a number on you, that you, and maybe that's what I'm saying, that I'm trying to overcome that which has been run on.
Yeah,
me.
well, that's the challenge always, and that's the point Mr. LaRouche has always made of, again, the irony of becoming comfortable with always being uncomfortable.
Mm.
That's actually what you seek. You sort of seek comfort in the appropriate uncomfortability. Because that's the thing, it's not just an arbitrary uncomfortable, like you just want to think chaotically or something and be like, yeah, I think the world's chaotic and I'm happy with that. But it's sort of the precision of ambiguity, which is really what you're searching for. That's what makes a great poet. Poets are very precise in their ambiguity. And that's what Kepler does. That's what all these great discoverers do, is that they locate the ambiguity, but they locate it in a very precise way, such that it's truthful in its precision, but you also know that it's not a definition. It's not a thing. It's not a definition. Yet it's very precise in the nature of the ambiguity of it. So, yes.
Did you say that Kepler discovered the harmonies of the world?
Yeah.
Okay, so this page says that Venus was left out of 5 planets. So when Bach and Beethoven, etc., make the composition, do they include all the planets? Only 4 planets in their compositions? Because Helga once told us.
Yeah, I mean, first, this page is just sort of, I kind of was trying to find a page from this book on the internet, and this kind of hastily grabbed this one. It doesn't really have exactly what I wanted on it. But, I mean, Kepler used all 6 of the planets in his composition, in his setting up of the musical system.
Okay, so what year was he born?
Kepler was born in,
Roughly?
I would guess,
1571.
Was that?
1571.
1571.
Okay, so that was before most of the German composers?
Yeah. He was, I mean, he predates Bach, and though, I mean, I am not the one to ask on the history of this. Actually, someone who Ben knows well. He's writing actually something on the history of the kind of the music that was going on in Kepler's time.
Okay, well, Helga once told us in one of her lectures that most of the German composers based their music was a description of the solar system. So, were they basing those compositions on Kepler's work, or was that something that came to them?
Yeah, there's some direct lines of work from people like Buxtehude and others, who was a teacher of Bach, who was inspired Bach, who was very steeped in the work of Kepler, who looked at Kepler, understood Kepler. I think it was Buxtehude, or was it Forkel? One of them actually said that Kepler was like the greatest musician of his time, or something to that effect. So there was definitely a direct lineage from Kepler and the breakthroughs he made in music, which of a different nature. I mean, he made a breakthrough in understanding that there's that he basically opened up the idea that you can have multimodal composition, in effect. That's what he did when he introduced this whole idea of hard and soft keys, and the fact that the solar system actually moves between 2 different keys, between the hard and the soft. And so that actually really opened up a whole new way of thinking about music, which then led into the revolutions of people like Bach and so on. Yeah.
I'd just like to state a realization that I guess I came across before and then really solidified right here. You mentioned that the irony of being comfortable or being uncomfortable, right? This form of mentality has the purpose of growth. That's the only reason, right? And so, like you said with the poetry, the beauty of poetry is its ability then to expand possibility and truly giving freedom being the definition of absence of limitations and the presence of possibility, right?
Right.
And so tying this back to what we're doing and thinking in this style, humanity then has to take this approach, accept it, internalize it, and continue to expand. And that one thing would then make a ripple effect.
Yeah.
And I think that's the purpose of.
It is exactly like you said, this idea of growth. Growth comes through that tension. Right? If something's just stable, comfortable, easy, it's not going anywhere. It's not growing. In all likelihood, it's actually degenerating, right? It's devolving. So yeah, exactly. It's through tension that growth and progress occur.
So it's funny because I've been hearing Kepler this and that, and I mean I think all the pieces came together and said, "Oh, this is why."
And next week you'll get there'll be a much more in-depth and rigorous sort of working through of some of his stuff, as far as I understand, with this cadre school and things. Yeah. I don't know how much time. Oh, I guess.
Take another.
Okay.
You can take another one.
Okay. Are you able to illustrate the usefulness of these other planets in relationship to Mother Earth, since we're so-called blessed with the privilege of life on our planet, and scientists are consistently trying to determine whether there is life on these other planets. What is the relationship of various other planets to Mother Earth?
Well, that's a good question. One, I think it's key to really not think of them separately, to understand that life exists in our solar system. Now it's most powerful here on Earth, but instead of thinking about there's life on Earth, there's not life on other planets, though it's important to figure out where life has been, how it's changed, etc. I think it's more important to kind of invert it and say life exists in the solar system. We have a living solar system. And therefore, however it may express itself on Earth, it expresses itself as a function of the system as a whole. Right? It's the whole system which is acting to determine activity of life on Earth.
Why are we
And Kepler actually does, I'll just say this, maybe, and this is something you might want to look at, that Kepler takes this up in a particular way. He, in book 4 of this Harmony of the World, he has, this is one on, if it has a specific title, but there he looks at these, what he calls the aspects, where he's looking at the way that the different planetary alignments produce certain types of relationships in the heavens which stir the souls of life and man on Earth.
Why are we so privileged?
Yeah, why not? I mean, that's a good question as to what is it about, what makes this the region which was able to carry life, but it's part of the whole system. It's part of the process. It happens to be here for reasons, but I don't think it wasn't a choice that was made in some kind of arbitrary, we'll put it here and not here kind of way. It's like the whole system, yeah.
That's why I'm raising the question as to how come we're so privileged to sustain life here on Earth and potentially nowhere else.
Yeah, well, and then the question is, can we then sustain life beyond our solar system? Because what we also know is that our sun is eventually going to
extinguish.
Right, which means everything in our solar system gone. And then we're still here, we're going to be gone too.
Yes.
But the challenge is then, can we, through this understanding, like you're saying, of what allows life to exist where it does, can we recreate that or supersede that such that we can spread life and the noetic process, the noetic principle, beyond the bounds of our solar system?
Okay.
Yeah, let me get him here. He
Oh.
already asked mine.
I didn't make that the last one.
Yeah. Okay, yes.
Okay, since you make the point that mind comes before matter, just what is your thoughts on the recent initiative, the BRAIN project that was sponsored by Obama, by others, basically doing, explaining like mental processes through brain processes, and that seems to be what the thrust seems to be. Do you have any comment on that?
Yeah, I would say, Obama's intention and those associated with him, I think, are probably malicious and ignorant. But, and I'll say, you're never going to get to mind through some sort of advanced neural mapping or something. You're never going to be able to recreate mind by having an adequate neural network which seems to replicate the neural connections of the brain. You're never going to get to mind. But in the right hands, that kind of development and technology could be very useful for having advanced robotics and things like that, which could alleviate man from a lot of the toils that burden him today. But you're never going to get to mind. Mind is something which can't be, as we discussed, can't be understood, stated, or replicated as in material form. It's something which is transcendent and can only, mind, sort of take Pasteur's idea that life can only come from life, mind can only come from mind. And so it's going to take, only mind can give rise to a noetic conception.
Thank you.